Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new numerical which is based on convolution of signals using inverse Z transform. So we'll study a problem number 2. Obtain the convolution of signals using Z transform, and the two signals are given. X1 of n is 0.25 raised to n u of n minus 1, and the another one is x2 of n is 1 plus 0.5 raised to n u of n. Now here in the first case the function is delayed by 1, and here we have to multiply u of n inside this bracket, and then we will move on to Z transform, or we can apply Z transform on both the sides. Now here the u of n is delayed by 1, so here we can use a time scaling property first, or else we can use a time shifting property first. Now in x2 of n, we need to simply multiply u of n inside this bracket. So what you will get, u of n plus 0.5 raised to n u of n. So u of n Z transform we can directly get, and in second part we have 0.5 raised to n u of n. So here also we are going to use a time scaling property of Z transform. Now we will apply Z transform on both the sides by using convolution theorem. First of all, we will solve x2 of n. I will multiply u of n inside this bracket. So my x2 of n is 0.5 raised to n u of n plus u of n. Now I will use a convolution theorem of Z transform. So let's say my y of n is nothing but a convolution of two signals, that is convolution of x1 of n and x2 of n. So if we apply Z transform on both the sides, so I can say that y of n is represented by y of z, whereas Z transform of x1 of n convolved with x2 of n is nothing but a product of Z transform of two individual signals. So from this I can say that we are going to apply Z transform of x1 of n and x2 of n separately, and then after that we'll multiply both the signals. So let's say this is nothing but my equation number 1. Now we will apply Z transform on x1 of n. So Z transform of x1 of n is nothing but x1 of z, and here we have 0.25 raised to n into u of n. So we can write, or we can use a time scaling property of Z transform over here. So according to time scaling property, we can write Z upon Z minus A, and my A value is 0.25. Now 0.25 can be written as 1 by 4, and if I multiply numerator and denominator by 4, then what you will get? (4z upon 4z minus 1). Now we will go for x2 of n. Basically x2 of n function is u of n plus 0.5 raised to n u of n. So which means I'm going to apply Z transform on this function. Now look at here. Here we are going to apply Z transform u of n plus 0.5 raised to n u of n. Basically, first of all, we cannot directly apply Z transform both this function. So we will use the linearity property first, and then later on we can use a time scaling property on 0.5 raised to n u of n separately. So according to linearity property, we can write this function as, we can apply Z transform on both these functions separately, and we know that Z transform of u of n is Z upon Z minus 1, whereas according to time scaling property we can write the Z transform of 0.5 raised to n u of n like Z upon Z minus A, and my A value is 0.5. But if I multiply numerator and denominator of second part by 2, what you will get? Now I'll cross multiply these two values. Now look at it. If z is multiplied with 2z plus 1, then you can write, after multiplying this z inside this bracket, you will get 2z square plus z, and here 2z square minus 2z. Now 2z square plus 2z square, answer is 4z square, and minus 2z plus z, answer is minus z, and denominator I can write this is the value of x2 of z. Now I will substitute x2 of z value and x1 of z value in my equation number 1. Now I have substituted my x1 of z value and my x2 of z value in my equation number 1. Now I'll multiply this whole bracket with this second bracket. So what you will get? 4z into 4z square. Answer is 16z cube, and 4z into minus z. Answer is minus 4z square, and denominator I'll write. Now basically, if we want to obtain y of n, which is nothing but a convolution of x1 of n and x2 of n, we have to place one z on left hand side. So I'll take one z common from right hand side. So you will get 16z square minus 4z. Now here we have three factors, so I can use a partial fraction method to calculate inverse z transform or y of n sequence. So I'll prefer three different constant, let's say a, b, c. So in the denominator of a we'll write 4z minus 1, and this is nothing but my equation number 2. Now I'll cross multiply this value, or you can say I'll multiply left hand side denominator on right hand side. So look at here, 4z minus 1, 4z minus 1 will get cancelled, so directly a is multiplied with z minus 1 and 2z plus 1. Look at here in b, z minus 1, z minus 1 will get cancelled, so b is multiplied with these two terms, and 2z plus 1 will get cancelled, so c is multiplied with these two terms. So what output equation you will get, I'll show you. Now here I'm going to substitute different values of z, so that you will get the answer for a, b, c constants. Now I'll substitute z equals to plus 1 in this equation. If I substitute z equals to plus 1, then look at it, 1 minus 1 is 0, so automatically this whole a product term is replaced by 0. Look at here, 1 minus 1 becomes 0, so will whole c product term replaced by 0, so you will get only for answer b. Now I'll substitute 1 on left hand side. So 1 square is 1, and 1 into 16 is 16, and 16 minus 4 is 12. This two term is replaced by 0, so we'll directly move on to this, as this z is replaced by 1, so 4 minus 1 is 3, and then here this z is replaced by 1, so 2 into 1 is 2, and 2 plus 1 is 3. Now these two 3's is shifted on left hand side, so we can write 12 by 9. And if we divide both this numerator and denominator by 3, you will get 4 by 3, which is answer of B. Now I'll substitute z is equals to minus 1 by 4. I'll substitute z equals to plus 1 by 4. So this z is replaced by plus 1 by 4, so automatically 4 and 4 will get cancelled, so we will have only 1 over here, and 1 minus 1 becomes 0, so whole c product term is replaced by 0. Similarly, look at here also, if this z is replaced by 1 by 4, then 4 and 4 will get cancelled, only 1 will be there, and 1 minus 1 is 0, so whole b term is replaced by 0, so you will get only of answer for A. Now I'll substitute z over here and only over here, because rest of the two values are replaced by 0. Now 16 get cancelled, 4 will get cancelled, so we'll have 1 minus 1, which is 0. So if we have a 0 on left hand side, so automatically my A value becomes 0. Now we'll move on to next. Now I'll substitute, I'm going to calculate a value of C. Now which bracket is missing over here? That is 2z plus 1. So if I substitute z equals to minus half, then automatically 2 gets cancelled, and this whole numerator is replaced by minus 1. Minus 1 plus 1 becomes 0. So automatically my A term and my B term will replace by 0. Now minus half square is plus 1 by 4. So 16 by 4 is only 4. This z is replaced by minus half, so minus minus become plus, but 4 by 2 is 2. Now as I said, if I'm going to substitute z equals to minus half, then A and B term gets replaced by 0, and we'll get the answer for C. So this z is replaced by minus half, so I can write directly minus 4 by 2 minus 1. Over here also I can write minus 1 by 2 minus 1. Now 4 by 2 is 2, so minus 2 minus 1 is minus 3, and here we have minus half minus 1, answer is minus 3 by 2, and this will be a 6. A product of minus 3 into minus 3 by 2 is plus 9 by 2, and I will shift that plus 9 by 2. Now I'll shift that plus 9 by 2 on left hand side, so I can write 6 into 2 by 9. Now look at it, if we want to divide, then we can divide 6 and 9 by 3, so this is nothing but 3 and this one is nothing but 2, so 2 2s are 4, so my C answer is 4 by 3. Now I will substitute all a, b, c value in my equation number 2. Now I have substituted my a, b, c value in my equation number 2. Now just multiply z on right hand side. Basically 0 upon anything is answer is always 0, so I'm not going to write this value in next step. So y of z is equals to 4 by 3, which is constant. I'll write first, and look at it, on both the sides we have a 4 by 3, so we can take 4 by 3 common. So inside this bracket we can write z upon z minus 1, and then z upon 2z plus 1. Now if I take 2 common from numerator and denominator, or else we can say that we'll divide numerator and denominator by 2. So if we do the same thing, then 1 by 2 is 0.5, so 0.5 is a constant, and z upon z plus 0.5 is the result. Now we will apply inverse z transform on both the sides. So what you will get, if we apply inverse z transform, then y of z is represented by y of n. Now 4 by 3 is a constant, so I'll write it outside. Z upon z minus 1 is nothing but my u of n, and then we have a constant term, that is 0.5. Now here we have z upon z minus 0.5. We can represent this whole equation like z upon z minus a. If I take minus sign common for 0.5, then you can write this equation as 0.5 raised to n into u of n. I'm using a time scaling property over here. Now here also you can take u of n common, so 4 by 3 u of n is multiplied with this bracket. So what is remaining inside this bracket? This u of n is replaced by 1, and this will be remaining, and this is nothing but the convolution of x1 of n and x2 of n. Now we will solve the same numerical but in different ways, but in next question. So for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.